Hello students, today we are going to see our next practical which is LCD interfacing. So first of all, what is LCD? So LCD is liquid crystal display. So LCD is a display and its full form is liquid crystal display. So this display we have to connect to 8051 microcontroller. Okay, so the aim of this experiment is to design and study the LCD and interfacing it, that means connecting it to a 8051 microcontroller. So by performing this experiment, we understand the working of LCD, how LCD liquid crystal display will work, and how we can write on display or read any data from the display. Okay, and to write a program for LCD interfacing with 8051 microcontroller. Then we write a interfacing program. Okay, so this is the circuit diagram of LCD interfacing. So this is the LCD display and this is the 8051 microcontroller. So look at this diagram. Here we use two ports of 8051 microcontroller. So P1.0 to P1.7. So this is the P1 port and P2.0, P2.1 and P2.2. So here port 1 is the 8 pins of port 1 is used for data and 3 pins of port 2 P2.0, P2.1, P2.2 are used for command. Okay, once again I repeat, the port P1, the whole port P1 is used for data and 3 pins of P2 are used for command. Okay, so here this is the LCD display. This is D0 to D7. So D0 to D7, this is the data. This is 8-bit data. So for this 8-bit data, we use 8 pins of port P1 and RS, RWE. RS means chip select. RS means chip select. This RS means chip select, or we can call it register select. Register select. RW, R slash W. R means read and W means write. Okay, E is enable. Now this RS means what? A register select. So what is register select? So in LCD there are two type of register. First is data register and second is command register. So out of these two register, which register is selected, which register we have to choose. So this choice is made by, or this selection is made by register select pin. So this is register select pin. This pin perform the write and read operation. This is enable pin. So here the VCC and VEE and the VSS and VE, and this is our VCC 5-volt power supply. Now we will see the function of each pin of LCD. Okay, now the D0 to D7 represent 8-bit data bus which carry the information to be displayed. Now this D0 to D7, this bit represent the information or represent the data that we want to display on our LCD display. So the message display on LCD, the message which is display on LCD is present in these are data lines D0 to D7. Then VCC is a supply to display. So this is the VCC. This is VCC, which is a 5 volt. So this 5 volt is provided to a LCD display to activate the display. Then next is VSS, is a reference point. That's it, ground. This VSS is a reference voltage which is connected to ground. Then next is VEE. VEE is the power supply contrast adjustment. So this voltage is used to adjust the contrast or to adjust the brightness of display. Okay, and the next is RS select command or data register. RS select means register select pin. This register select pin select either command register or either data register. Now, if RS is equal to 0, then command register is selected, and if RS is equal to 1, then data register is selected. If this pin is 0, then command register is selected, and if this pin is 1, then data register is selected. Okay, now the next pin is read and write pin. Here read and write pin, the read and write pin is used for read and write operation. If this pin is 1, then read operation is performed, and if 0, then write operation is performed. If this pin is 1, then read operation is performed, and this if this pin is 0, then write operation will perform. Okay, Now the next is enable. Enable the internal latch of LCD. So high to low pulse cause the internal latch to be enabled. So E pulse must be at least 450 nanoseconds wide. So this enable pin is used to enable the LCD, to enable or disable the LCD. Once again I repeat, so this is the interfacing diagram of its LCD display. Okay, so this is 8051 microcontroller. This is the port P1 of 8051 microcontroller, and this is the port P2 of 8051. Okay, so here port 1 is used, the whole port 1 is used. That means each port has 8 pins. So all the pins of port P1 is used as the data lines. So here D0 to D7 are the data lines or data bus. The information that we want to display on a LCD display are present on these data lines, and these data lines are connected to port 1 of 8051 microcontroller. Okay, now the next port is P2.0. So only three pins of port 2, only three pins of port 2 is are used here: P2.0, P2.1, P2.2. P2.0 is connected to the RS pin. RS pin is a register select pin. So there are two type of register in LCD: data register and command register. So these two register are selected by RS pin. If RS pin is 0, then command register is selected, and if RS pin is 1, then data register is selected. The next is read write pin. So read write pin is used to select the read operation or write operation. If this pin is 1, then read operation is selected, and if this pin is 0, then write operation is selected. This pin is connected to P2.1 of 8051 microcontroller. The next is enable, which is connected to P2.2 of 8051 microcontroller. So this enable the LCD. Now VCC, this is the VCC. VCC is supply voltage, which is 5 volts. So this 5 volt provided to activate the LCD. The next one is VEE. VEE means it is a contrast voltage. So this voltage adjusts the brightness of display or contrast of display. Then VCC, VSS. This is the reference voltage which is connected to ground. Okay. So this is all about LCD. Now here the here the table is given which lists the various command that LCD perform. So first is the following table gives the control word in control word in hex and the effect in cost to LCD. Okay, so this is the commands. So first is clear display. So to give this command clear display, we send one hex value. So return to home. So for this command we use this, we send these two numbers in hexadecimal format. Then shift cursor left. So for this command we use four value. So shift cursor right we use 6. Shift display right we use 5. Shift display left we use 7. So all these values are present in a hexadecimal. So if we want to shift the display left, we send 7 number in a hexadecimal format. So when this 7 number receive at a hexadecimal format, then LCD will understand that we have to shift the display left side. Okay, we have to shift the display left side. So by performing this operation, we send their particular value to a LCD. Both display and cursor off. If the both display and cursor should remain off, then we send a 8 number in hexadecimal format. Display off, cursor on. So this operation we send A. So display on, cursor off. For this operation we send C. So display on, cursor blinking, we send E and F hexadecimal number to LCD. Then for shift entire display to left, shift entire display to right. For these two operations we send their particular hexadecimal code. Then force cursor to the beginning of first line, force cursor to the beginning of second line, two lines. So for these operations or for this command we use their particular hexadecimal code. Okay, so for each of these operation we perform by sending their respective hexadecimal code to a LCD display. So if we send a C hexadecimal, this hexadecimal code C, then LCD will perform display on cursor of operation. Okay, this command will be performed by LCD when we send this C hexadecimal code. Okay, now these are the, so before going to write a program, here are some steps. Okay, the logic of the program is given in the following steps. First, declare a character array for strong command word and configure the display. First of all, here we declare the character array for command. Now, which command we have to send to LCD? Which command we have to send LCD? So we list that command and make a array and declare that array. So first of all, we declare the array of a command that we want to send to LCD. Okay. Then next we declare the array of message. The message which is to be displayed on a LCD display. So the next step is the declare array of this message. Declare the array of message. Okay, first we declare the array of a command. So this command contains the various operation that will perform on LCD. Okay, then we declare the array of message which is to be displayed on display. Then next is set the P2 bits of writing data to command register. Then here P2 bits are connected to a command register. So the third step is we configure P2 bit for command register. Okay, then point to the first element in command word array. Then the next step is first element in a command array will selected. First element in a command array is selected. Then send it to P0. Then send it to P0. Then the first command will be selected and this first command sent to a P0 port. Okay, make enable bit low to high. Okay, then point to next element. Then we again come to the next element of command word. Then we again come to the next element of command word, and that next element sent to a P0 port. So all the command words are sent to P0 port. Okay, then set P2 bits. Then set this P2 bits for data register. Then set this P2 bits for data for writing a data on data register. Then first element of message array will send to P0. Then second element of data array is sent to P0. Okay, so in this way the message will display on LCD display. Once again I repeat the steps. First is declare the array of a command register. The command register contain different command that we want to give to LCD display. So this command array contain various command. Then we declare the array of message. So this array contain the message that we want to display on LCD display. Then set the P2 bits writing the command to command register. Then we set the P2 bits for command register. Then the next step is the first element of command register is sent to a P0. First element of command register is sent to P0. So after sending first element, then we send second element of command register to P0. Then we send third element of command register. So in this way all the command will send to the P0 port. Then the next step is set the P2 bits for writing data on data register. Then again we set the port 2 bits for writing a data on data register. So after setting the P2 bits for data register, we point to the first element of message array. Then the first element of message array sent to P0. After sending first element, the second element of message array sent to P0. Then third element sent and fourth element sent. So in this way all the message sent to the LCD display, and after sending all the characters of message array, sending the LCD will display this word or this message on their display. Okay, on the display after sending all the elements within the character array, within the message array, the display this information. Okay, so these are the steps. Now we come to the program. Okay, so this is the program for LCD interfacing. The first is hash include range 51. So this is the header file of 8051 microcontroller. This is the constant unsigned character command word. So here we declare the command word array. So here the command is 38. 38 means what? Here 38 means 2 lines, 5 into 7 matrix. Okay. Then next command is 0e. E means display on cursor blink. Okay. Then the next command is 01. 01 means what? 01, clear the display. Okay, so in this way the command is display in a the command is defined in the different commands are defined in a command word array. Okay, so the first step of the program display the array of storing command word. So here we declare the command word array. The next step is declare the character array of storing the message to be displayed. So that means here we declare another array which contain the information that we want to display on display. So here HELLO, so hello. So this word will be displayed on LCD display. So for displaying this word, so we declare the array of this message. Okay. Then we take another variables which is in the form of integer I, J and K. So here we declare delay function. Here we declare delay function, then void main function. So within this void main function, this is the while loop. This is the while loop. So within while loop, why we take while loop? Because this message is continuously display on display. So therefore here we take while loop. Now the for loop. For command array there are 5 commands, 0, 1, 2, 3, 4. So there are 5 commands. So here we take the for loop for 0 to 4. I is equals to 0, I less than equal to 4. So here we take the for loop for command array. Then P0 is equal to command word. P0 is equal to command word. So that means configure the display by sending appropriate command and then set the cursor position. So here the particular command is sent to a P0 port. Here particular command is sent to P0 port. So the first element of the command word is 38. So this first element sent to a P0 word. Okay. Now P2 is 40. Now what is the P2 of 40? So here P2. So this is the port pin of P2 port. So out of this P2.2 is unable here. P2.2 is unable, 2.1 is read write, 2.0 is rs. Okay, so here unable, so we want to activate the LCD. So this pin is 1, read write, we perform the write operation. So therefore read write pin is 0 and rs. So first we send the command to a 8051 microcontroller, and command register is selected when this pin is 0. So therefore we make this pin 0. So the data become 40. So therefore 40 value is sent to P2 bits. Okay. Now the next is the delay. So after sending 40, it gives some delay. Then again send a value 00. Why it gives a delay? So after sending first command, then it takes some delay, and then next command will be selected. Then third command will be selected. Then fourth command will be selected. Okay. So here we send all the command to P0 port. Now here we send information or message. So for message we take for loop. Now here also there are 5 words in the character in the message array, in the data array, 1, 2, 3, 4, 5. Okay. So here we take for loop for I is equals to 0 to I less than equal to 4, I plus plus. So here we take the array for this message word. Okay. Again the first element which is H is sent to P0 port. The first element in the data data array is sent to P0. Now then we again set the P2 bits for data register. Now here P2 for the data. So P2.0 to put P2.7 to P2.0. Now the enable bit to activate the LCD, we P2.2 pin will be high. So we have to write the information. So here we make this pin 0, because if this pin is 1, then read operation is performed, and if this pin is 0, write operation is performed. So here we write the data, so therefore this pin make 0. Again, rs is register select, we have to select data register. So here we make this pin 1. If this pin is 0, then command register is selected. So here we select the data, so therefore this data register this bit make high. So the code for these bits are 0 5. So here we give a 0 5. Okay, then it give delay, and then again it gives 10 10. This is the enable pin, it should be 0, because the lcd is deactivated, and after some time it again activated and saying next character. So in this way each character is sent to a data register, and after sending each character to from the data register, then the lcd will display each character. Lcd will display each character. Now this is the delay function. This is the delay function. This delay function represent the delay for j is equals to 0, j less than is equals to 255, j plus plus, and k is a delay function. So k is equals to 0, k less than equal to 255, and plus plus. So here we take the 255. Why we take 255? Because our data is lcd will work on 8-bit data. LCD and controller will work on only 8-bit data, and for 8-bit data the value is 256. 2 raised to 8. 2 raised to 8 is equal to 256. So for 8-bit data we take the delay of 255. For 8-bit data we take the delay of 255. Okay, so in this way we program the LCD to interfacing the 8051 microcontroller. Okay, so this is our. So by performing this practical, we know the working of a LCD, we understand the working of a LCD and understand the program for interfacing. Okay, so now we will stop here. In next lecture we will take another practical. Okay, now we will stop here.